Today we will learn time domain analysis of first order RL and RC circuits. Here we can see one resistance, one inductance connected in series, and we are applying a DC voltage source. As this course is designed only for the first year BTech students under Mac out, so we are dealing with the DC source with RL and RC circuits. So I have used one simulation package PSpice for this. Here I can see that the current through the inductor is increasing gradually. So I will discuss all these things. Here it is RL circuits where current is increasing gradually. Here it is one resistance and capacitance are connected in series, and we are applying 2 volt DC. Here also we can see that the voltage across the capacitance is increasing gradually. Initially it is 0. So we will learn the theory behind it into T means again L by R. So this is equal to 0.3679 IS. So we have seen the transient current I is equal to 0.3679 IS. So current through the circuit I is equal to steady state current minus transient current. So this is equal to, we know the value of IT is equal to 0.3679 IS. So IS minus this, so we are getting 0.632 IS. So this is actually 63.2% of IS. So at tau, 1 tau, this value is 63.2% of IS. Now the term L by R is called the time constant. Time constant, and it is denoted as tau. Transient part of the solution is I is equal to minus V by R e to the power minus R by L into T, or this is equal to minus V by R e to the power minus T by tau. So tau is equal to L by R. After 5 tau, the transient part reaches more than 99% of its final value. The voltage across the resistor, VR is equal to Ri. This is equal to R into R. I means V by R, 1 minus e to the power minus R by L into T. So R cancel. This is equal to V into 1 minus e to the power minus R by L into T. So this one is the expression of VR. Similarly, voltage across the inductor VL VL is equal to L di dt. So this is equal to L. Now I'm putting the value of I, ddt of V by R, 1 minus e to the power minus R by L into T. So we have to differentiate this one. And this is equal to, so this is L, then V by R, then we are differentiating this e to the power minus R by L, so it will be R by L into e to the power minus R by L into T. So this R and L are cancelled. So this is equal to V into e to the power minus R by L into T. This one is the expression for VL. Therefore, VL is equal to this. So VL is equal to this. Similarly, VR is equal to this value. Now power in the resistor. Power in the resistor we denoted as PR. This is equal to VR into I. So this is equal to VR means we have VR is equal to V into 1 minus e to the power R by L into T. So V into 1 minus e to the power minus R by L into T into I. Again I is equal to V by R, 1 minus e to the power minus R by L into T. So we can see this one is the V square by R. So this is e to the power minus just 2 into this. So it will ultimately a minus b into a minus b equation. So this will be 1 minus 2 e to the power minus R by L into T plus e to the power minus R by L whole square. So it will be e to the power 2 minus 2R by L into T. So this one is the expression of power in the resistor. So power in the power in the inductor PL PL is equal to VL is equal to VL into I. This is equal to V into e to the power minus R by L into T into I means V by R into 1 minus e to the power minus R by L into T. So PL is equal to again V square by R e to the power minus R by L into T into 1 minus e to the power minus R by L into T. So this is equal to V square by R e to the power minus R by L into T minus e to the power minus 2 R by L into T. So this one is the expression for power in the inductor. Now see these examples. Say the voltage source is 10 volt. Now it is connected to an inductor. Okay, this one will be your resistor. 10 volt is connected to a, see this circuit. This is 2.5 ohms. This is L, and this is 10 volt. Time constant is given. Time constant tau is given as 1.6 second. We don't know the value of L. So L by R is equal to 1.6. So L is equal to 1.6 into R. R means 2.5. So this is the value of 4. So 4 Henry. So current I is equal to V by R. This is V by R into 1 minus e to the power minus R by L into T. So this is equal to 10 by 2.5 into 1 minus e to the power T by tau. So when T is equal to 1 second, we consider T is equal to 1 second. So at that time it will be 1 by 1.6. We are finding current after 1 second. So this will be your 4 into 1 minus 0.535. You can use calculator. So this is the value is 1.86 ampere. So this one is the value after the value of current after T is equal to 1 second. Thanks for watching. For more videos, please subscribe, share and like.